to need some colored pencils or pens or something in order to make your notes with me. So if you want to just follow along and do that, you're going to want some different colors. You don't have to use the same colors as me. But the goal behind today is to do our station model notes, and away we go. All right, this is a station model, or an example of a station model. It's, and what we mean by station model is weather station. And so when we create, not me personally, but when people, the agencies, create weather maps to tell us what the weather is it raining, is it snowing, is a hurricane blowing, which way is the wind blowing, how fast is it blowing, what's the temperature, what's the dew point temperature, what's the current pressure reading, all that good stuff. They produce one of these guys, or one of these, and these are very simplistic examples. But it gives us a lot of information. So I'm going to show you how we're going to turn this into all of that information I just talked about. So you can just follow along and create your own notes. That would be great. And then I'll show you the little worksheet and we'll talk about that. Okay. So if I were to make a representation of this, because I'm going to create some color-coded notes. So there's a circle in the middle, and then there's this area right here, and 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 this area right here. And you can see that this little thing moves, but I'll talk about it. So for this one, I'm going to put it off in this direction. I'm going to draw the same one because we're just going to talk about it. Then there's others that you won't see on my station models, but I will talk about them. They go along this middle section, but none of the ones that you'll see on the quizzes or the test or anything like that will have those. But I'll talk about them just in case, you go out there looking and you're like, what the heck does that mean? So I'll talk about them. All right, so we're going to start in this area right here, and you'll notice they're not really in boxes. I love it when people draw them, because on this side of the worksheet you have to actually draw the station model, and they put them in boxes because that's how we made our notes. They don't go in boxes. I'm just showing you what goes in that region, but that, in my opinion, is the easiest way to talk about what goes in that little region right there. So we're going to talk about what goes in this little box, and I'm going to use blue to talk about it. So here we go. So in this little blue area right here is one of the easier parts of this particular diagram. In fact, most of it's pretty easy. There's only one kind of tricky one. It's over in this area, and that's temperature. If you could do me just one favor, and that is, if you can't see what I'm writing, holler at me or post it in the chat, because I've got the little chat window right here. But if you holler at me, then I'll be able to fix that quickly so that your colleagues who are not with us right now have something to do. So I'm also going to put like an example. I'm going to actually put this example in this upper right hand corner. I'm just going to copy it. And again, this is on the back of your worksheet. So just so that we have like a context as we're going through this to talk about. Plus and 0.006. Okay. So if we look in this little area up here, it says 28. And the most you'll have to do with that is possibly convert from Fahrenheit to Celsius or Celsius to Fahrenheit. And I'll ask you if you have to. But the temperature is the temperature. So if it says 28 degrees, it's 28 degrees. If it says, 37, it's 37 degrees. But there is, in your worksheet, you have to convert from Celsius to Fahrenheit. So I'm going to give you the formula for that. So the fast way is just to essentially multiply it by 2 and add 32. That's the quick and dirty way. That's the not so accurate but close enough for government work. Although I always say that, and then I finally looked it up and I was like, yeah, government work's pretty precise. So I'm not sure where that saying came from. But it's always how I remember what the formula is. So to determine the temperature in Fahrenheit, you're going to take the temperature in Celsius and you're going to multiply it by 9/5, which is 1.8. So I'm just going to write it as 9/5. And then up here, I'll put 1.8 just in case you want to put it in as a decimal. I mean, yeah, as a decimal. And then you're going to add the 32. And the reason is that the Fahrenheit scale, like 0 in Celsius is freezing. And 0 in like freezing in Fahrenheit is 32. So you have to account for that like shift in numbers, and then they're 1.8 degrees apart. So that's why you have to add in that 32. If for some reason you were, and back when we were in class together, unfortunately we did this math with calculators, but I know, just as you probably know, that if I were to ask, for example, Alexa, what is the current temperature in Celsius? Right. She wants to help me with my favorite book. So the first thing you have to do is subtract that variable, that 32, and then you're going to multiply that by the inverse of this, which is 5/9, which is also known as a repeating number of 0.555555. So we'll just put a 6 in there in case you wanted to know what that was. But I'm sure I have no way to control for it, so why would you do anything different than say, hey Google, what's 28 degrees in Fahrenheit, if that's what you were asked to do. But back in the day, we actually had to do the mathematical, conversion. All right, so below that area is this area in here, and it's related. It's the dew point temperature. And if you remember from last week's definition, the dew point temperature is the temperature at which, so I'm just going to label this, temperature comes out of water vapor and turns into a liquid again. And so in this particular case, the temperature, the dew point temperature is 25 degrees. So, oh, I guess I could put that in here. Dew point temperature is temperature, since we are taking notes, where water vapor becomes liquid water. And so I'm just going to put a nice big blue box around this because everything in this blue box is related to the blue parts of my little thing here, so that I can remember. Remember, I said colorful notes. And if you're following along, when we get all done, you'll be able to just turn this in, you'll be done. Okay, so that's these two things here. We're going to hold off on this guy for a second, and we're going to do something a little more complicated. I'm going to use red. You can, like I said, you can use any color you want. The idea is just that you're making them colorful. All right, so this is going to take me some time as far as space is concerned. So I'm just going to start with my little red box here, and then I'll start talking about it. Okay, so these three digits up here relate to the air pressure, current air pressure. And these stations are updated every 3 hours, just so you know. So it was the pressure when it was last measured. And they're measured, every 3 hours, and I don't know, probably starting at midnight and then 3 and then 6 and then 9, for all I know. I don't know when. I just know it's done every 3 hours. So I'm going to put this number in here just so when I talk about it, I know what I'm talking about. So 006. Now, a couple of things about air pressure is it's already automagically, it's one of my favorite words, converted based on your elevation. If you were in my lecture class, you should be familiar that pressure changes based on three things: humidity, altitude, and temperature. Automagically, it automatically does that. So there's nothing we can do. So it would be inaccurate for us to report it straight off. So what they do before they, create these little stations is they've already adjusted based on standard pressure. And standard pressure on our planet at sea level is 1012.4. In case you're ever, on Jeopardy and you need to know that. So basically, what that means is air pressure on our planet adjusted for elevation is between 950 and 1050. And you're like, okay, Pitts, how are you going to get a 950 or a 1050 and put the 006 somewhere in there? Well, in order to save space and printer's ink, but more space than anything else, what they did is they dropped this number off. Okay. And so you're like, okay, great. And they got rid of the decimal because we're still at 006. So you're like, well, okay. So basically what you're going to do is you're going to take whatever that number is in that area. So in this case, we have 006. And you're either going to put a 9 in front of it or a 10 in front of it. And you're going to put in the decimal. So the first thing you do is you put in the decimal. So you just put the decimal in, right? And then it's either going to be start with a 9 or a 10. And it has to be between 950 and 1050. So in this particular case, it would have to be 10 because 900.6 is below 950. So it always has to fall on there. So let's do another one. Let's say it was 768. Okay, start by putting in the decimal. Then either a 9 or a 10 in front of it. And that's how I still do it to this day. Yes, I mean, for those of you who are more numerically aligned, I'm a spatial learner. So, that's why I teach geography, because it's spatial. Ha! Or I'm spatial, or both. Obviously, if it starts with a number above 5, it's going to start with a 9. If it starts with a number below 5, it's going to start with a 10. But I just do it this way because I think it's faster. But if you want to, figure it out, you could write that down. So 0 to 5, well, actually 49, 499. It's going to start with a 10. And then if it starts with a 5 to anything else, it's going to start with a 9. But I always think that's hard because what we're talking about, so I guess if it's 500 or above, so greater than 500, no, is it this way? I can't remember. Yes, it goes like this. If my number is greater than 500, then yeah, something about Pac-Man, and I can never remember, which is why I never do it that way. I just do it this way. All right, so we'll do one more just for good measure. 232. So I either put a 9 or a 10 and start with a decimal. Looks like it's going to be a 10. So what that means is this is 1023.2. This is 976.8. This is 10,006. I always forget to be explicit with these things. So. Okay, so that's what goes in this area here. Oops, right here. Just below that is a box that's related. So I'm going to keep it in the same thing because it's related to air pressure. And it's the change in air pressure. That's a delta in air pressure over the last 3 hours. And again, in order to save ink and time and energy, and to make it as confusing as humanly possible, they do a number of things. Again, it's dealing with air pressure, so the first thing you have to do is put the decimal in. So in this particular case, we're at plus 0.2, so I'm going to put that in brackets, plus 0.2, just so that I know as I'm talking about it what we're talking about. So plus obviously means it's gone up, so plus equals increase. Oops, forgot the A. Minus obviously is going to be decrease. That one's pretty easy. And then 0.2, so we have to put in a decimal. So 0.2 becomes 0.2. So if it said instead 10, it's 1.0. Remember, we're putting in the decimal. You always have to put in the decimal. So 0.2 can also be written just as 2. And that's the same thing, because again, we're putting in the decimal point, right? So just think of them as saving ink. Lazy. It was more about the fact that decimal points, first of all, early typewriters couldn't really put in periods. And the printing process, at times, ink would get thrown on the page. And so it would mess it up if it accidentally fell in the wrong spot and they were trying to report the correct pressure. So they just said, you know what, forget the whole decimal point thing. Yeah, so. All right, there are other ways to show increases and decreases. So I'm just going to make a little table down here. So another way to show an increase is a line sloping up. Or sometimes they'll use like an arrow or a line sloping down to show a decrease. And then the opposite of that would be a down arrow. Made my line a little too long. There are some other symbols. One of them is this one. That means it's remained steady. Means it hasn't really changed all that much. And then to have fun, what they do is they put this with these things. So it could go like this. So this would mean it increased and then it became steady. Right? Or decreased and then steady. And then my favorite, well, it went up and then it went down. Right? So they just kind of throw them together. There's one other thing that you might have to do. In fact, there is a question on your worksheet. If you're doing the worksheets, it says to convert to millibars. And I'm going to give you that formula. But again, I'm sure you can just ask Siri if you ever needed to. I don't think there's any test questions on it, but you're supposed to know how to do it. So we're just going to put it in our notes. So I'm just going to create a little separate box here for the formula for converting from inches of mercury to millibars, because these are in millibars. So if you're given inches of mercury, you're going to take the number of inches and you're going to multiply it by 33 point, I have to look this one, 86, 37, 26, 86, 37, 26. Oops. And if for some reason you needed to get, inches times this equals millibars. If for some reason you were given millibars and somebody asked you to do inches, so you'll take the millibars and you will multiply them by 0.029530 and that will give me inches of mercury, which you should never play with because it's toxic. But I remember when I was a kid, I played with it. Don't tell my mom. Get in trouble. It's cool because, all right, I shouldn't tell people. Well, you're not kids. You won't go out and play with these things. Don't tell your children. But when you break like an old mercury thermometer, which are hard to find, it goes into little balls. Like it coagulates together and it creates like this little ball. So you shouldn't play with mercury. Just, yeah, okay. So that's the air pressure part, which is these two little spots right here. All right, now we're going to talk about what goes in the middle. I'm going to cover it. I'm going to color it green. And obviously I need another piece of paper. So I'm going to leave that up there just so you can see it, but I'm going to talk about it. All right, so what goes in that green area, or what that represents, is the amount of sky that is covered in clouds. Cloud cover. And it ranges from no cloud cover to an abundance of cloud cover. So it's either going to be clear or it could be all colored in. So this would mean it's really, really clear. 0% of the sky is covered in clouds. Here, it would mean 100% of the sky is covered in clouds. We call that cloudy. We actually call anything technically more than 3/4, or like half cloudy. Well, we call that partly cloudy, but this would be, oh, I forgot to say, this is clear. This is cloudy. Halfway between that, we would only half of the little thing would be colored in, right? Between these two is almost like pieces of a pie. Gonna go with 1/4 of it would be colored in. 3/4 of it would be colored in. There are some other fancy ones, like the one that's in here is just like a little strip down the middle. And I just like drawing it. And the one over here is all but the strip in the middle. But most of the ones you'll see will fall into one of these, 4 things. So that's cloud cover. Now, remember where I talked about that there's other things, you're not going to see them in this class, but there are other things that go in this area here that are related to cloud cover. And they have to deal with what types of clouds are there. So for example, if I, Google station model symbols, these are all different types of clouds. And so depending on where they are, so if they're high elevation clouds, it might be a symbol that looks like this, and so it would be up in this area. If it was a middle elevation cloud, it would be just above the circle in this area. And then if it was a low elevation cloud, it would be down in this area. But you're not going to see them on in the test or anything, but I wanted to let you know, just in case you ever saw one, you're like, what the heck does that little symbol mean? So these are just different types of clouds. And so, like a cumulus cloud, which is the fluffy ones and stuff like that. So just, FYI. case you go out looking at station models in your spare time. All right. Okay, the next part I'm going to talk about is this little guy right here. We call it a flag and feather. Okay, so that deals with wind speed and wind direction. It tells you both. Okay, so it's the wind direction is where the wind is blowing from. Where wind is blowing from. And yes, it makes a difference because, well, another confusing thing in geography is basically what this is. Do you describe the wind as where it's coming from or where it's going to? So when they say it's a southeast wind, is it blowing southeast or is it coming from the southeast? Well, technically it's coming from the southeast, which means it's really a northwest, but yeah, you're just going to describe the wind based on where it's coming from. So it's important to know never eat shredded wheat. I have a gluten allergy, so that's what I grew up knowing. And then we have like these in-between ones. So we have like northeast, which is, yeah. And then we have southeast, and then southwest, and then northwest. And then we can get really fancy. Like, you won't see them on my quiz, but this would be northeast. And this one here would be east, northeast. But we're not going to get that detail, just so you know. The winds that are coming from somewhere are either going to be north, east, southwest, or northwest, or northeast, or northwest. It's not going to be one of those intermediaries. Okay? And again, it's where the wind is blowing from. As far as speed is concerned, we're going to use the little stick and feather. These are called feathers, which are fun, in my opinion, because this is how I've always thought of it. So I remember it talks about where it's coming from. If you imagine this being an arrow, like when you were a kid, little arrow, and it had little feathers on it, then it's pointing towards where it's going. So this shows you where it's coming from. So this is where the wind is from. So if it's just an empty stick, which this one isn't, but if it were an empty stick, that means that the wind is not very crazy. It's between 1 and 2 knots, which stands for a nautical mile. Now, a nautical mile means how fast you can travel on water. Because there's less friction on water, you can actually travel a little bit faster, but we're not going to talk about that in our class. We're going to just say that knots are the same as miles per hour. A knot is technically 1.01295 miles per hour. So it's a little bit faster. But for our intents and purposes, miles an hour and knots, you can write it the same. Don't have to get all complicated. We're just going to call it miles per hour because it just makes it easier for us all, because we're familiar with miles per hour. And in fact, when they talk about wind speed on the telly, they say, oh, 20-mile-an-hour wind, which, once it gets over 100 miles an hour, it's really not 100 miles. It's actually, well, it is still 100 miles an hour, but it's really 101 knots, 110 knots. So you can go 10 miles faster if you were on a boat than if you were on land, just for the record. All right, so I call that the naked model. Okay, so if it's just a little stick, that means it's going between 1 and 2. If there is no wind, it'll be naked. There won't be anything on the little cloud model. So it's always connected to the little cloud circle in the middle, and it can just be a stick. All right. If it has a short feather, then it's 5 knots or 5 miles an hour. If it has a long stick, then it's 10. Sometimes they're drawn at an angle. They might be like a real feather like this. Just depends on who's making the model, how fancy they want to be. But they mean the same thing. And if it has a little flag, that means 50. So then they just start combining them. So if it was something that looked like this, it can be filled in or not filled in. It doesn't matter. How fast is my wind blowing? Anyone? Anyone? In what way? Looking in the chat. Or you can, unmute and tell me.
Would it be 75?
Yes, perfect. Thank you. Yes, 75, 50, 60, 75. Perfect. See? And so when you get into like hurricane country, you get like multiple little flags like this, and then a whole bunch of little sticks like this, and then a longer stick like that. So, so those are essentially what you might run into as far as this is concerned. And it's a wind from the east at 75 miles an hour. So it's a 75 mile an hour per hour wind from the east is the best way to describe this. From east, in case you need to describe it. So for example, on the back of your worksheet this week, it says wind speed direction, you're right from the southeast in that particular case. All right, so because I drew my little stick in black on the front of my notes, see, I'm just gonna leave that in black. All right. There's one other area that I have not colored in yet. I'm gonna make it orange. The last time I did this, I did it in purple, and the purple and the blue is really hard to see. And so it was really hard. So I'm gonna use orange this time. But again, you can use any color you want. All right. This box here is kind of special. Remember how I said they don't use periods, they don't do anything fancy, they're always trying to save ink. Well, except for where it comes to this area right here. Okay, so what goes in that area is weather, which is something we here in California are not familiar with. You're like, I thought this was the weather station model. It is. But all of this stuff, minus that little orange box that I colored in, is stuff that we would see on our station models every day of the year. It's clear, warm, low humidity. So it's going to have a, low dew point temperature, stuff like that, right? Pressure going up and down, yada, yada. Okay. But in other places, they actually get weather. In fact, when I taught weather and climate at Victor Valley, it was the first place I taught weather and climate. I joked for like the first 4 weeks. I'm like, when they asked me to teach weather and climate, I was like, great, this is going to be a great class. We never have any. What are we going to talk about? Because if you listen to the news, sunny and warm, sunny and warm, sunny and warm, clear and warm, clear and hot, clear and this, clear and that. And you're like, okay. I'm actually experiencing some clouds today. There was a little bit of drizzle. I was kind of excited. But I live on the windward side of the mountain. So, all right. So there's 3 classifications that you might find in this area. Yeah, go ahead.
Move it up a bit, please. We can't see it.
Oh, sure. Thank you.
Thank you.
No, thank you. Because yeah. I can see it perfectly fine, regardless of. So thank you for telling me. All right. So, And what they're going to do is they're just going to put extra symbols based on what they are. So for example, a dot means rain. So a light rain would be 1 dot, and a moderate would be 2 dots. And then a heavy rain might be 3, or it might be 4, depending on heavy, or just kind of heavy. Sometimes they line them up like this instead of creating this little triangle, but that's what that's for rain. All of those are rain symbols. Okay, a little asterisk looking thing like this. Well, that's snow. It's like a little snowflake. See, you have to remember what they might have on their keyboards back when they were typing. Okay, so that's like light snow, moderate snow, heavy snow. There's a little comma looking one, and that's just drizzle, which is, you know, like super light rain. I don't know how better to describe drizzle, except for it's super light rain. It's what happened here today. It wasn't really rain. My housemate ran out. It's raining. I'm like, no, it's drizzling. Shouldn't we cover the furniture? No, it's drizzle. It'll go away. And then another one is a little triangle. So you don't really, well, I guess you can have, I guess you can have heavy drizzle, but isn't heavy drizzle just rain? I mean, come on. So, but that's the symbol for drizzle. There's one other one. It's a triangle pointing up, and that means hail. So you guys might see that on a weather station model up in the high deserts. Every once in a while, you get a nice thunderstorm with some hail. So another symbol you might see is a triangle pointing down, and it would have one of these things on top of it. So if it had a little dot on top of it, that means it's a rain shower. So this just means shower. And a few years ago, a student raised their hand and said, "What's the difference between rain and a rain shower?" And I said, "It's the difference between standing in your shower and turning on the spigot and being able to turn it off, and standing in your shower and not being able to turn the water off." So if it's raining, that means essentially for the next 3 hours, you're going to have water falling out of the sky. If it's a rain shower, that means it's going to rain and then it'll stop raining, and then it'll rain and it'll stop raining, kind of thing. So that's kind of the difference. Oh, so yeah, that means it's pouring. A rain shower means it's coming on, it's going to come down. You can have a heavy rain shower. You could have just a light rain shower. It just depends. Shower has to do with whether or not it's intermittent. So these would be if it's like just raining. Remember, these are updated every 3 hours. So if it's just raining, you're going to have one of these. If it's a shower, so it'll rain and then it'll stop, and then it'll rain and it'll stop, then they'll put the little shower symbol on there. So you can also have snow showers. You can have hail storms, things like that. One of my favorite ones is this guy. Let's see if you can guess what this guy is. We'll give it. Any guesses?
Lightning or thunderstorm or...
Very good. It is a thunderstorm with hail and rain. Probably not going to see that on a quiz. It's too hard to draw. I should make one, though. That would be kind of cool. I could probably copy it out of one of these. Let's see. Oh, yeah, look it. Yeah. Oh, they have like multiple zigzags in theirs. So there's other ones. So a tornado looks like this, and ice crystals look like that, and freezing rain. And so there's lots of fancy little symbols and stuff like that. But and then see down here are all the showers. I like these. Miscellaneous sky cover. So all of this stuff in here, all of this stuff here, this stuff here, and this stuff here would all be in that weather box or area. Sorry, it wouldn't be in the box. It would be in this area right here. So, but you're not going to see anything more than what we've pretty much drawn here. So you're good to go with just this. All right. So if you followed along, take copies of these little pictures and you can turn them in and you're done with your notes or your required activity for this week. Way to go. Way to go. Good job. Okay. But before I let you go, let me talk about the activity for this week. So your activity for this week is to decode some of these station models. On the front side, you're going to take the information and create station models. And then you're going to answer a couple of just like thinking questions, critical thinking questions. And then these, you're going to take the stations and you're going to decode them. You're going to figure out what they all mean. So we kind of did this one. So let's do this one together. So the current air temperature at our station is 28, right? What is the dew point temperature? That's okay, you can turn them in. I don't care how ugly they are. They're your notes. If you can read them. You can redo them if you want. But all right, dew point temperature at this place.
Is it 25?
It is, very good. What is the current wind speed?
$15.
Yep. Wind direction?
Southeast.
Yeah. Barometric pressure? You're either going to put a 9 in front of it or a 10 in front of it and a decimal. It has to be between 950 and 1050.
10.
Yay! Okay. Barometric trend? So again, that's going to be in this area right here. So that gives us this right here. So what's happened to it? We look at our notes, it says it went up because it has a little plus. And then we have to put in a decimal. So it went up 0.2, technically millibars, but even on the quiz, it's not going to ask you to put in millibars. It's just going to ask for a number. So just put up and then 0.2. All right, what about cloud cover? Going to be represented as a percentage.
100%.
That's right. Ooh, here's one I didn't talk about. All right, it says, well, I talked about current weather. It's snowing. But I forgot to talk about whether or not what this number means. That number is the visibility, and it is what it is. So if it says 1/2, it's a half a mile. If it's 1, it's 1 mile. If it's 3, it's 3 miles. So this is the only place you're going to find numbers that don't, well, that's not true. Everything on this side essentially doesn't really, the numbers are the numbers. Everything on this side, the numbers are not the numbers. So visibility is 1 mile. So I forgot to talk about that one, but it's in that weather area. Okay, so that's what you're going to do for these. You're just going to, you know, okay. Then on the front, let's create one. So let's see, air temperature is 32, so that's going to go in this area here. Notice there's no degrees, no Fahrenheit symbol, nothing. You just write the numbers. Okay, dew point goes down here. So I'm just using my notes. Oh, I guess I could label this air pressure. Change in air pressure. Weather. Cloud cover. Wind speed. Direction. Oops. This one moves. None of the rest of them are going to move. Okay, wind speed, 10 knots. But we have to know which way it's coming from. So it's from the west. So never eat shredded wheat. So that's going to be a line this way. And it's 10, so it's going to be a long one. If you noticed, I forgot to mention this, but if you noticed when I drew the 5 one, I didn't put it at the end. You're never going to see a short stick at the end, a short feather at the end of the stick. It'll always be in. So you can gauge, like when you look at the backside, the long and short. So they always put the short ones in. So even if it's only 5, it'd be by itself and it would be on the inside, if that makes sense. So if it's at the end, no matter of its length, see how these look a little shorter than these? If it's at the end, it's definitely going to be a 10 or a triangle. You're never going to find a 5 at the end of the stick. Okay, it'll be like indented a little bit. All right, barometric pressure. Again, this is the hard one. Okay, we haven't gone the other direction, so let's do it together. I'm going to put it in my notes because then I'll have this when I take my test and stuff. So I forgot to talk about how to take it back the other direction. So let's give you the one that's on the paper, 1012.2. So if we're putting in the decimal and taking off the 9 or 10, we're going to do the same thing. So we're going to drop the 9 or the 10 at the front, and we're going to take out the decimal point, right? So this becomes 122. So I'm just going to say remove 9 or the 10 and the decimal. Put that in my little thinking cloud right here. Just so that I remember later on. That way I only have, like, you know, in this particular case, 2 pages of notes to go through while I'm taking my tests. All right. Barometric trend 3.2. So again, we're going to drop the decimal. We're just going to write in the number, and it went up. So I can do that anyway. I'm going to go up 32. No decimal, no precipitation, cloud cover 50%. Color in half of my little circle. I'm going to give you this number. It's 998.9807. So you don't even have to do the math on that one. And then this is 64. And this is 46. All right. Have a nice week, everybody. I will see you next week. Yeah, life is good.